Hello, so I am Parth Khandelwal, your peer, one of your peer from class 11th, and I just studied atomic structure partly, and I'm just gonna explain you some of the topics which it has, which are Dalton's atomic theory, its limitation, cathode ray experiment, properties of cathode ray, and Millikan's Altrop experiment, and Thomson-Eheim experiment, and magnetic field, and uh, anode ray experiment and its properties and all of this stuff. So let's just begin with it, and I'm also going to show you notes, by the way, so that we can you can read what I'm speaking of. And let's go. So here we have atomic structure, beginning of the chapter atomic structure. First things, Dalton's atomic theory. He gave us 5 points, which are: atom is the smallest non-divisible particle of any substance. Atoms are of same elements are similar in every due respect. Third point, atoms of different elements are dissimilar. Fourth point, atom can neither be produced nor be destroyed. And fifth point, atoms combine in ratio of small whole numbers. Okay, so just repeat with me. First, atoms are smallest non-divisible particle. Second, atoms of same element are similar in every due respect. Third, atoms of different elements are different in every due respect. Fourth, atom can neither be produced nor be destroyed. And fifth, atom combine in whole ratios. But here it is all wrong which I just spoke, but we have to study anyhow, so there are some limitations of it. First limitation is that it can be destroyed, and it also can be reproduced by artificial transmutation. Okay, and second thing, that atoms can be divided into infinite number of elementary particles like neutron, electron, proton, etc., which proves it wrong for atoms are smallest non-divisible particle. Third, that atoms it is proving that atoms of same element are similar in every respect false, which is atoms of elements of same element may differ by their mass number, called isotopes. Okay, and then we also have the last one, that atoms of different elements are dissimilar in everyday respect. We are proving it false by stating about isobars, and isobars are different elements which are having same mass number. Okay, here it is, Dalton's atomic theory and limitations completed. Now we are there talking about cathode ray experiment. So what just see this diagram here. What do we do in this cathode ray experiment is that here is a kind of apparatus, a tube which has vacuum pump, and the reason vacuum pump is present is that it sucks all of the air, and only 0.01 mmHg pressure is left there. And just to give you context, our air pressure is 740 mmHg, and this is just 0.01 mmHg. So you can just see that only just vacuum is not there, just you can say vacuum tending to zero is there, which allows particles to pass through it, inside it. And second, we have HVR, high voltage rectifier, connected with it, and it is of, like, we are applying voltage of 10,000 volts. And just to give a context again, our home just received 220 volts, and here it is 10,000 volts. And even this cathode ray special tube has discharge tube has ability to tolerate pressure of 15,000 volts. Okay, and so what do is we apply potential difference of 10,000 volt, like we apply we just switch on that electricity, and with 10,000 volts we apply pressure, and cathode rays go from negative to positive direction, and some kind of radiations are emitted, and they named it as cathode ray because they originate from cathode and have wave nature. Okay, you can just read here after pausing. And I know that my handwriting is not very visible or not very good, but you have to tolerate with that. Okay, and then we have properties of cathode ray. So cathode rays, first thing what did we do is that we just have inserted a paddle wheel here, as you can see, and that paddle wheel rotates once once we turn on electricity. That shows that some kind of particles are moving. And why does waves why waves does not move here? Waves could also turn them, but the reason waves aren't moving here because waves are not able to create motion, whereas particle does have. So the rotation of this flywheel shows us that cathode rays are of particle nature. Next thing, what did we do is we just have put positive electric plate on the upper side of the cathode ray and negative electric plate on the lower side. So what happened was that the cathode rays deviated from electric plate towards positive electric plate. And then next thing what we did was we have just just imagine we have just dropped a magnetic plate on that cathode tube, horseshoe magnet on that cathode tube, and so we have north and south pole. So what did we notice that cathode rays deviate towards north pole. Okay, so mm, so and also we get to know that path of charge particle in magnetic field is circular and path of charge particle in electric field is parabolic. And next thing we did was that we just have put a material here and a fluorescent screen here, as you can see. So what did we notice that this material was its shadow was being formed at the fluorescent screen, and that fluorescent screen is made up of zinc sulfide. And so the act of shadow being formed suggests that the cathode rays travel in a straight line. Okay, and then we also get to know one more thing about penetration power. So when cathode rays are allowed to incident on that metal foil, so it will go through that foil, it will pass through that foil, and that shows that it possesses penetration power, and penetration power is inversely proportional to mass. That means that the less the mass, the more the penetration power. And okay, so here I have the first question, and we just have to write down the order of penetration power of particle: alpha, neutron, proton, and electron. So what do we have is that we know that alpha is equal to 4 times of proton, mass of alpha is equal to 4 times of mass of proton. Neutron is almost equal to mass of proton but just bit greater than that. An electron is 1 by 1840 of proton. Okay, so mass is alpha is most greater than neutron, then proton, then electron, and so penetration power is inversely proportional to mass. So it is electron is greater than proton is greater than neutron is greater than alpha particle. Okay, got it. And next point we studied was that when cathode rays are allowed to incident on that heavy metal like lead or tin, so their kinetic energy, the kinetic energy of cathode ray, is converted to heat energy, and that is they show heating effect. And the next property we studied was that speed of cathode ray is approx 2.18 into 10 to the power 6 meter per second. And then don't ask me how is it just is. Just you have to learn this what we studied. And the next part is related to 12th class. It comes in class 12th, but they just taught us. So I'm just gonna give you brief. If you understand, then it is well and good, and if you do not, then also it's fine. So when they are allowed, when radiation when cathode rays are allowed to strike on heavy metal, so new type of radiation is produced, which are called X-rays. So you know what happens, see here electrons are revolving, and once these cathode rays are allowed to incident, they just throw out these electrons to get their position back in, and this happens so radiations are emitted out from it. Okay, and I know that most of you might not be able to understand it, but okay. And next thing, that cathode rays cathode ray destroyed photographic plate. So here it is, a photographic plate, and in it has silver bromine and silver iodine. And what happens is that when cathode rays are allowed to incident on it, then decomposition reaction happens, and I believe that you all have learned this reaction in class 10, so no worry. And then another thing, that when cathode rays are allowed to pass through a gas, then it will ionize the gas. Okay, that is the possess ionizing power. What happens is that when cathode rays are allowed to incident, they just throw out these electrons and only positive charges left. That is, they show ionizing power. They ionize this gas, and ionizing power is directly proportional to mass of it. And now again we just have to write down ionizing power of alpha, proton, neutron and electron, and we got to know from here that mass is alpha is the most greatest mass, then neutron, then proton, then electron. So it would be same, because ionizing power is directly proportional to mass. And now what conclusions can we infer from it? We can infer that cathode rays are originated from cathode, which is the flow of negatively charged particles, and they must be okay. So when we get to know that they are originated from cathode and their flow of negatively charged particles, then it is clear that a new kind of atoms or a part of atom, subatomic particle, would be emerged, and that subatomic particle we name as electron. And the next thing, that you know what, we did Mulliken did a oil drop experiment, but it will come in deep in class 12, so we just have to memorize it, that, and we really don't have to care any damn thing about Mulliken's oil drop experiment, what happened and what not happened. We just have to care what things he inferred out. And so first thing he inferred out was charge on electron is 1.6 into 10 to the power minus 19 coulomb, and which you might know in electricity in class 10th. And second thing, he found out the formula for charge, which is Q equals to NE, which is also derived from which is also given in class 10 electricity chapter, so no worry. Q here shows the charge, and N here shows the number of electrons, and E here shows the charge of electron, which is 1.6 into 10 to the power minus 19 coulomb. And charge of electron is negative E, which is minus 1.6 into 10 to the power minus 19 coulomb. Okay, so here it is. We have completed these all stuff. Like you can see, it is a lot: atomic structure, Dalton's atomic theory, its limitations, cathode ray experiment. Cathode ray experiment is very deep. Even the one through whom I learned, physics wala and my coaching's mentor, it comprises of things from both of them. So it is the most detailed version which you could ever see on this entire YouTube. And I've also given you some questions of these things and conclusion about it, and about Mulliken's oil drop experiment. So that is it for today, and I hope you could see my face here, and this is what I learned today. So thank you for watching this, and bye bye.